Hi everyone, welcome back to our day 5 of ongoing Power BI training session. So today we are stepping into one of the most important parts of Power BI, which is data modeling. Think of data modeling as the foundation of a building. If the foundation is weak, the entire building collapses. Similarly, in our Power BI also, if the data model is poorly designed, no matter how fancy our visual look, the insights will be misleading. So let's start by loading some tables from our SQL Server database, and then I'll walk you through relationships, star versus Snowflake schema, and the best practices to build a clean data model. So for our first step, let's load some sample table from the SQL Server database. So here in our Power BI desktop, we will click on the Get Data. We will select the SQL Server database as our data source. Here we will add the server name. So this is my server name. We have two connectivity modes, which is import and direct query mode. Import mode will import the data in our Power BI file, and direct query will be connecting with the database as a like live connection. And every time we create a visual, it will fetch the values. It will generate an SQL query which will fetch the values for that particular visual. So we will go with the import mode. Here, let's select the database from which we have to load the tables. Here we can select the tables. We'll click on the load. So as you can see in our right side data pane, we have all the tables loaded perfectly. We can go to the table view and we can see the data also inside the tables. Now let's talk about the model view. So these tables together will form the backbone of our schema, which will be going as a snowflake schema for our case. So here the fact table is the sales table, which will be the central table, and we have some related dimension and also some subcategory dimension as well. So how a relationship works in Power BI? It is similar to joins. We can say it is very similar to joins. But in Power BI, we have three different types of relationship. So the first one is one-to-many relationship. For example, one customer in the customer dimension having many sales record in the fact sales. So that's why our customer dimension will be considered as one and the fact sales will be considered as many at the time of creating relationship. Then we have many to many relationship. So many to many relationship is something, let's say we have student table and we have the subject table or courses table. One student can join multiple courses. Also, one course can have multiple students. So it's kind both the places. Many situation is happening. So that's why this kind of relationship is called many to many relationship or a bridge table. The third relationship type is one to one, which is the least used relationship, but it is also very important. Let's say we have an employee table in which we are storing the employee ID, employee name, and employee hire date. Again, we have another employee detail table where we are storing the employee ID with employee age, employee date of birth, employee salary, employee department location, address, phone number, email, etc. etc. So every record in employee table is also a unique record, and every record in an employee detail is referring to one record in employee table. So every record in employee detail table is also unique record. So the both tables will be in relationship, one-to-one relationship in the model. One record of employee table is matching with another record of one record of employee detail table. So that is our third example for the one-to-one relationship. Let's create our first relationship. So we will click on the manage relationship. We have an auto detect option. If we click on this, it will fetch for the relationships, like fetch for the common uh, column names in the tables, and if it finds, it will create relationship between them. But as of now, we will not click on the auto detect. Let's create our first relationship. So in the front table, I will select our fact table. In the to table, I will select our customer dimension table. So here you can see we have the customer key in both the places, and the name is also uh, similar. So that's why it detected automatically those tables. Now in the cardinality, you can see it is many to one. It means that for one customer in the customer dimension, having many sales in the fact dimension, sales fact. So one customer is referring to many sales rows. Then again, we have the cross filter direction here considered as single, and this relationship is active. If we click on save, we can see we have our first relationship created. And as you can see, this is our first relationship. If I zoom in, you can see there is a arrow direction from customer to fact dimension, fact sales. So what it is referring to, if we want to filter the fact sales with help of customer ID or customer name or gender, we can do it from customer side to the fact sales cells. But if we want to filter the customer table with sales sales ID, we can't, because the direction of the filter is only one directional. So again, we can click on this. We can change the direction to both the cross filter direction, and we can apply security filter, and we will save. Here you can see the direction became both places, the cross sectional. So it is very helpful when we have to filter the fact also with dimension and dimension also with the fact. So now I'll just quickly create all the relationship with the help of auto detect, because we are having some similar column names. So here, just by clicking auto detect, all the relationship created automatically, and it's correct also, because I have the common table column names. Now this is our Snowflake schema. I'll explain about what is star schema and what is Snowflake schema. Yes. So star schema is a schema where we are having one central fact table surrounded by multiple dimension tables. So let's say if we have fact sales, and we have time dimension, we have product dimension, and we have customer dimension only. Let's not let me just come to this layout. I'll just drag the fact, I'll just drag the product, I'll drag the time, and I'll drag the customer. If I arrange this, we need one more table to show it like a star, but still it is looking like a star. So this star schema is having one central table connected with multiple dimension tables. So in our case, the sales is the fact table, and product, customer, and time is the dimension table. So this is looking like a star. Here we don't have interconnected dimension with the dimension. So I'll explain about the Snowflake schema. So when dimensions are further normalized into multiple small tables, let's say we have this pro customer, and here we have the region. So each customer is having in different region. So the customer is having a subcategory of region as well. So those kind of data model is called a Snowflake schema. So why which schema is better? If we talk about the schemas, which schemas is very better? So star schema is better in Power BI because it is having simple relationships. It is having faster queries, easier for end user to understand. And if you talk about Snowflake schema, it is very complex. Here the performance is also slower than the star schema. And because we have multiple interconnected dimension and sub-dimension tables, so it is taking longer time to execute queries or measures to fetch the data. So we can look at our model to identify that how any dimension looks like a snowflakes or a star schema. So here clearly we can see our this dimension, the customer dimension is interconnected with our another subcategory, which is the region. That's why this is a snowflake schema. So now for you guys, what you can do, you can just search for some sample data sets with some relationships, or else if you want, I can share this tables with you so that you can create some relationships and you can use those relations data and you can create some metrics by after creating the data model, and then you can check about the data validation, how the visual is looking, how it is working. For example, let me create a simple measure which is total sales. So I have total sales. I'll drag into the canvas. Now I'll drag a product name here. So if I click on AC Clover product, I can see the sales is only $32,000. Let me just change it to the dollar sign. If I click on the albendazole, so we can see the sales for albendazole is 13,000. Let's say if we don't have a relationship between sales and the product, I delete this relationship. See, if I click on this any of the product, this thing is not filtering just because we don't have active relationship. That's what relationship matters in our the data model matters. Strong model matters in our Power BI. Again, let me create the relationship back. Now again, you can see we are again able to filter our sales record with the help of product names. So today what we learned about the types of relationships. We learned about the star schema and the snowflake schema, and we learned how to clean our like how to create a clean data model. So let's talk about some best practices while creating a data model. So always prefer a star schema because star schema is better than a snowflake schema. It is faster, it is easy to create, and it is easy to understand. Use surrogate keys like integer IDs for relationships. Create and mark a proper date table always because the date dimension is the most important dimension in so many data models. Avoid many to many relationship, or if required, use bridge tables. Hide technical fields like IDs, which is not required in our reporting part, so we can hide it. And rename table and field. Let's say here dim underscore time. It is not a good way to show our table and like columns like the with the underscore with the small structure. So we should rename it with the business friendly names. So these are the best practices which we should follow while creating a data model. So I would like you guys to do basic hands-on practice with some small data sets, some multiple fact and dimension table or some small tables, and you can practice this. So in our upcoming classes, we will be discussing about the Power BI DAX. We will start writing DAX queries. We will start writing some basic calculations, and we'll start developing some visuals with the help of those metrics. So thank you. Bye bye.